Comet 3 I/Atlas has recently become the center of attention for astronomers and space enthusiasts around the world, especially after a wave of concern spread when early reports suggested that the interstellar visitor might have broken apart or even exploded. These alarming claims emerged shortly after the comet reappeared from behind the far side of the Sun, a moment when astronomers were eagerly waiting for fresh observations. A report by Futurism on November 10th fueled this anxiety by highlighting an analysis from Harvard astrophysicist Avi Loeb, who published a blog post asserting that 3I/Atlas may have lost a significant portion of its mass. Loeb based his conclusion on a single image captured by two small telescopes in Spain on November 9th, arguing that the comet's appearance hinted at fragmentation. However, Loeb's statements quickly drew criticism from many experts, not only because they were founded on limited data, but also because he has developed a controversial reputation for frequently suggesting alien involvement in natural astronomical phenomena. His previous claims about interstellar objects such as Oumuamua being extraterrestrial spacecraft have already caused debates within the scientific community, and now these ideas were once again resurfacing in connection with 3I/Atlas. Despite the dramatic nature of Loeb's assertions, the broader scientific community has remained calm, confident, and grounded in the available evidence. While the search for extraterrestrial life is an exciting frontier, scientists emphasize the need for cautious interpretation, especially when dealing with sparse data or ambiguous imagery. One of the researchers pushing back against the fragmentation theory is Qiqing Zhang, a postdoctoral fellow at Lowell Observatory in Arizona who has been closely studying the comet. In an email to Live Science, Zhang stated that all the observations he has reviewed so far show the comet behaving normally. According to him, the images reveal a healthy comet with no indication that its nucleus has split into pieces. His expertise, paired with the consistent observations collected by multiple telescopes, presents a reassuring contrast to Loeb's more speculative suggestions. Zhang stresses that if a comet truly breaks apart, astronomers typically see clear structural changes, uneven brightness, visible fragments, or chaotic dust dispersal. None of these signatures are evident in the latest images of 3I/Atlas, reinforcing the idea that the comet remains intact and continues to follow its natural evolutionary path as it journeys through the solar system. The momentary disappearance of the comet behind the Sun added an element of suspense for observers. Known as perihelion, this closest approach to the Sun occurred on October 29th, and during this period, the comet was hidden from view by the overwhelming brightness of our star. Such moments always generate curiosity because a comet's behavior can drastically change under intense solar heating. Some comets brighten spectacularly, others fade, and a few do indeed disintegrate. When 3I/Atlas emerged once again on the other side, astronomers were eager to see whether it had survived the intense temperatures and radiation. Fortunately, the comet's reappearance has been smooth, and its brightness patterns suggest that it is not only stable, but also undergoing the typical processes expected at this stage of its solar passage. As 3I/Atlas approaches and then moves away from the Sun, it undergoes dramatic physical transformations driven by heat. Comets are composed of ice, dust, and rocky material, and when sunlight warms their surface, the frozen components begin to sublimate. That is, they turn directly into gas without passing through a liquid phase. This sublimation creates some of the most iconic cometary features. Gas and dust can erupt from the surface in powerful jets that resemble miniature geysers, blasting material into space. These volatile eruptions can reshape the comet's surface over time, carving pits, exposing fresh ice, and sometimes producing bursts of brightness that observers on Earth can detect even from millions of miles away. The newly released gas and dust also form the coma, a glowing cloud that envelopes the comet's nucleus. The coma can grow extremely large, sometimes thousands of kilometers across, and is often the most visible part of a comet to observers on Earth. Beyond the coma lies the comet's tail, a sweeping luminous structure that forms as solar wind and radiation pressure push dust and ionized gas away from the nucleus. Comets often have two distinct tails. the dust tail, which shines by reflecting sunlight, and the ion tail, which glows because charged particles emit light as they interact with the solar wind. During 3I/Atlas's passage near the Sun, astronomers have been watching these features closely, as their shapes and brightness can reveal important clues about the comet's composition, temperature variations, and rotational patterns. These processes are particularly interesting for scientists because 3I/Atlas is not just any comet. It is an interstellar traveler, meaning it originated outside our solar system. Objects like this are extremely rare, and only a handful have ever been detected. Each interstellar object offers a precious opportunity to study the conditions and materials present in distant star systems, giving us a glimpse into environments far beyond our own. As 3I/Atlas continues its journey, researchers are analyzing its chemical makeup by examining the light emitted or absorbed by the gases in its coma. Differences in chemical signatures can point to unique formation processes or environmental influences from its home star system, helping astronomers understand how comets elsewhere might differ from the ones native to our solar neighborhood. From Earth's perspective, the comet is now rising higher each day above the eastern horizon, creating favorable viewing conditions for both professional astronomers and amateurs equipped with relatively small telescopes. Those with a 6-inch aperture telescope in many parts of the northern hemisphere can already catch sight of it under dark skies, especially in the early morning hours. The brightness of the comet, enhanced by the sun's radiation, makes its tail and coma more noticeable, allowing observers to witness features that would otherwise require much larger instruments. For many stargazers, the opportunity to see an interstellar comet is incredibly rare and exciting, as most visible comets originate from our own solar systems, Oort cloud, or Kuiper belt. Even though speculations about alien spacecraft naturally attract public attention, astronomers emphasize that extraordinary claims require extraordinary evidence, and so far, everything about 3I/Atlas suggests a natural origin. Its motion follows predictable gravitational patterns. Its activity matches that of typical comets heated by solar radiation, and its visual structure aligns with what scientists expect from an intact nucleus undergoing normal sublimation. The scientific community continues to collect data, refine models, and compare observations from multiple observatories around the world. As more measurements come in, researchers are building a clearer picture of how this comet is evolving, and everything points to a stable, unbroken celestial object, behaving as physics predicts. In the coming weeks, astronomers will continue monitoring the comet as it moves farther from the sun, watching for changes in brightness, tail structure, and gas production. Some comets brighten significantly after perihelion, while others fade more quickly. The rate at which a comet dims can tell scientists how quickly its volatile materials are being depleted. For an interstellar comet like 3I/Atlas, such data can provide insight into what types of ices it contains, whether they are similar to those found in typical solar system comets or contain exotic compounds rarely seen in local objects. Amateur astronomers are encouraged to observe it as well, as widespread observations help create a more complete picture of the comet's behavior from different angles and atmospheric conditions. For now, though, one thing is clear: 3I/Atlas has not exploded, disintegrated, or vanished. Instead, it continues to glide gracefully through our solar system, glowing brighter as sunlight energizes its icy core. The comet remains intact and scientifically valuable, offering researchers a rare window into the chemistry and behavior of a visitor from another star system. While sensational claims may capture public imagination, the steady work of astronomers across the globe ensures that the true story of this remarkable object is based on evidence, observation, and scientific rigor. As our interstellar visitor moves onward, it continues to inspire curiosity, reminding us of the vast diversity of objects traveling through the galaxy and the many mysteries still waiting to be uncovered.